Hi there, welcome back. This is Mustafa Ahmed. First of all, I'd like to say sorry for being late. I know it's been a month since I posted the last video of techlog, but I had stuff to do, graduation stuff. Today I come back with good video. In this video, you'll learn resistivity, density, and gamma ray log responses. So this video is important for students and for the beginners with techlog and with logs in general. So keep on watching and let's start. So let's start, but before we talk about techlog or before we work on techlog, I want to explain something right here. I'll talk about log response. So we'll talk about resistivity, density, and gamma ray logs. Like for every single layer, for sandstone, shell, these logs have different response. I want to explain that because these things are essential and you have to know it. So I will explain these things first and then we'll go back to techlog. So I'll suppose that I have sandstone here and shell right here. So we have two types of formations. And here I'll talk first about gamma ray. Gamma ray. I'll explain what is gamma ray and how it works. Gamma ray starts from 0 and ends with 150. And the unit of gamma ray is API. Wait, let me do something different right here. The curve will be in a red line. And after that, let's see the resistivity response. I'll talk about deep and shallow lateral log. We have two types, as you know. I'll explain these types too in this video. But right here, let's say we have lateral log, deep, and lateral log, shallow. The unit of resistivity logs is in ohm. In ohm, and the scale is in log scale. So it starts with 0.2 and ends with 2000. For the shallow and deep. Yeah, let's take the blue one for the deep and the green for shallow. Alright, so here I'll put density logs. About two types, Robbie or bulk density, and the neutron porosity, M5. Robbie starts from 1.95 and ends with 2.95. You have to know the units of these logs and the limits of these logs. And the units of Robbie is gram per cubic centimeter. Here, N phi starts from 0.45 and ends with 0.15 minus. And the units of it is in percent. So let's select the color. The Robbie is in black. All right. So here, let's talk about gamma ray before we see its response. So gamma ray responds to the radioactive material in the formation, like potassium, uranium, thorium, and it's used to calculate the shell volume. It's used also to determine the limits of the formation. We can use it to uh, uh, to select the perforating depth, but this is a little bit advanced, so uh, let's escape this and we'll talk about it later in perforating. If we make perforating course, we'll talk about this thing. When we have sand, it will have it has a low radioactive material in sandstone, so the uh, the response will be low, and then it will increase in shell because it has high radioactive material. So this is the response of gamma ray when we have sandstone and shell. So now let's talk about resistivity logs. As I said, that it has two types. Uh, First one, lateral logs. And the second one is induction logs. Now, when can we use lateral log and when can we use induction logs? When we have low conductivity mods, we use induction logs. Like when we have fresh water, for example, if we drill the well with fresh water, fresh paste mud, we can use induction log. When we use or when we or the lateral logs run in high conductive mud, like salt water or salt based mud. So when we drill the well with salt based mud, we use lateral log. And here in this example, I used lateral log. So here I have lateral log deep and lateral log shallow. So now, let's see its response with sandstone, and let's suppose that this formation has gas at the top and oil here. First in the deep, and after that the shallow. Here you might have a question about this. Now, why deep is higher than shallow? To answer to this question, let me show you this. Uh, we have shallow lateral log work on this area, while deep works on this, and this zone is far away from the invasion of the mud. Now let's say we have oil in this zone. The oil in flash zone is pushed by the invasion of the mud to the transition zone. So this zone will have water and oil, and because of that the response of this zone will be lower than this zone, because the resistivity is response higher with the hydrocarbons, and this area is oil and it doesn't have water from invasion, so it will be higher than the shallow. Now when it's reached to shell zone, let's say we have water right here, and the water is salt, of course. The resistivity for shell and salt water is low. Now the resistivity for salt water and shell is much lower than the resistivity for hydrocarbons. So it will be like this. So this is the response of resistivity for sandstone and shell, for hydrocarbons and water. Now let's talk about the density logs. As I said right here, we have gas at the top and oil, and after that we have shell and salt water. So how does the density logs will respond in these zones? Um, as you know that the gas has low density, So the rho b, or the bulk density, will be low. Now it's black right here, the rho b. And for neutron will be low too. So it will be like this, because the neutron is start from here. This is the minus 0.15. Oil has higher density, so it will be like this. And the same for bulk density. And when it reaches to shell, it will be high. And the same for neutron. So from that we know that we have gas right here and oil right here, and here we have shell. So let's say we have water in this sand zone. Let's see the response of phi. Let's say the response right here. So we saw the response of density logs in shell. Now let's see if we have water right here. So I will delete this. And the response will be like this. The water, the Robbie will get close to the neutron log, and it will be like this. So when you see this, you will know that you have water in sand formation. And this is the main thing you have to know. So let's go back to techlog. Now let's see the response of these logs. So when you see high gamma ray, it means that you have radioactive material, as I said. So when you have radioactive material like potassium, uranium, thorium, so it means that you have shell. And the response of Roby and fine, wait, let me edit this. You have to notice the limits of these units, the limits of the logs. So here we have 0.45 and the upper limit is minus 0.15. And here we have to edit the limits too. 1.95 and the upper limit is 2.95. So when we have shell, the response of Roby will be high, as you can see here in the red curve, and the response of neutron will be high too, as you can see here. So it means we have shell. And if we go down, the gamma ray response will be lower than this. So it means we have sand right here. And here in density logs, as you can see here, the neutron density goes down to the lower limit, and rho b goes down too. So it means we have gas or oil right here. Here we have water, and the same thing for the rest of the well. And I don't have resistivity in this well, so I'll select another well. All right. So as you can see here, the gamma ray response is high, and it has low resistivity. And of course, because the shell has salt water, and the response for resistivity for salt water is low. That's why we have low. That's why we have low response for resistivity logs. So when we go down, the gamma ray response will be lower, and the resistivity logs will respond higher than this zone. So it means we have hydrocarbon right here. So we can say this is the zone of hydrocarbon. And the same for the rest of the well. This is what I have for today. Thank you for watching. Hi there, welcome back. This is Mustafa Ahmed. In today's video, you'll learn since I posted